All right, good morning, guys. I'm really sorry about yesterday's video. I had no idea that the sound wasn't working. I also did not realize you guys cannot see what I'm writing on the board. With that in mind, I'm going to try to tape today's class by taping the screen with my phone, so hopefully this works out. If there are any issues, please let me know, you guys. I'm sorry, I didn't watch the video, so I didn't realize that there were issues. But for today's class, which was yesterday's, I'm going to cover experimental probability versus classical probability. And you might also have on your note sheet empirical probability. So what is it? What's the difference? Classical probability is ideally what would happen. So an ideal situation. So for example, if you want to pick a heart out of a deck of cards, the probability of picking a heart would be what? 1/4, because 1/4 of the deck is hearts. But realistically, you might not actually pick a heart card if you do that 4 times. So experimental probability is what really happens. And that's when you're going to use a chart. Or you're going to use data that was given. Okay, so then if you look, I have a situation with Skittles. Now for both, you're still going to do P over Q, and P is always a smaller number. So with the Skittles, we have red, orange, yellow, green, blue, purple. And when you picked out of the bag, you picked red 6 times, orange 3 times, yellow 8 times, green 7 times, blue 9 times, and purple 5 times. So let's see what the total is. How many times did you pick out of the bag? So 6 plus 3 plus 8 plus 7 plus 9 plus 5. So when I add those all up, you picked out of the bag 38 times. So that's going to be Q. Alright, so with that in mind, let's answer some questions. Alright, using the data table, so what I just went over, determine the experimental probability of getting a yellow Skittle. So we picked out of the bag 38 times. Yellow was 8 times, which means it's going to be 8 over 38. And then that reduces to 4 over 19. Alright. Next up. Determine the probability of getting a yellow Skittle when the classical probability, with classical probability. If there are 30 Skittles in the bag, and there are 5 of each color. Okay, so now we're not going to use the chart. We know that there are 5 of each color, so that means that there are 5 yellow, and there are 30 Skittles total, so it's going to be 5 over 30. Put that in your calculator. Alright, now going back to the data table from the previous page. Experimental probability of grabbing a red Skittle. Then replacing it and picking a blue Skittle. Alright, so I have 2 situations here, which means I need 2 P and Qs. And I replaced it, so there are always going to be 38 Skittles. I picked it 38 times. And then, let's see here, I want red. Red is 6. And then I want blue. Blue is 9. So then I'm going to make my 2 fractions and multiply them together. 6 over 38, 9 over 38. Put those in the calculator, and then hit math, enter, enter. going to get 27 out of 722. Alright, next up, determine the probability of getting a yellow Skittle, not replacing it, and picking a purple Skittle using classical probability. So, not the chart, where there are 30 Skittles, 5 of each color. So we have two situations here. You'll notice that you are not replacing it. So first there are 30 Skittles, then there are 29. I want purple, so there are 5, and yellow. Should have those reversed, 5 and 5. So we get 5 over 30 times 5 over 29. I'm going to type that in the calculator and hit math, enter, enter. And I'm going to get 5 over 174. All right. Next up, we are going to go back to what I assigned, and I want to do, I believe it's this one. Yep. Okay, so again, we're going to use the data table. We're going to go back and forth between experimental and classical, or experimental and theoretical. So theoretical is classical. That's when you're just rolling a die in an ideal situation. So what is the theoretical probability that an even number will be rolled on a cube? Let's see here, even numbers. 2, 4, 6. So that's 3 out of 6, which reduces to 1/2. Alright, what is experimental probability of how many times an even number was actually rolled using the table? Okay, so I want to use the table, and first I need to add these numbers up to see what my Q will be. So 8 plus 3 plus 9 plus 6 plus 4 plus 6. Alright, looks like you rolled the die 36 times. Okay, so I know that the denominator is going to be 36. Even number, 2, 4, 6, that occurred 3 times, 6 times, 6 times. So 3 plus 6 plus 6. So 15 times. Alright, and let's see if that reduces. And it does. 5 over 12. Alright, if you roll a number cube 36 times, how many times would you expect to roll the number 1? Alright, you guys, this one's really weird. Don't overthink this. So, if I want to roll a 1, I have a 1 in 6 chance. Now, I want to roll though that cube 36 times, so it's going to be to the 36 exponent. Your answer is going to be crazy, so just leave it like this. Alright, next one. How many times did you actually roll the number 1 in the experiment? So now looking at the chart, I'm rolling a number 1. Looks like I rolled it 8 times out of the 36 times that I rolled the die, and let's see what that reduces to. Two over 9. Alright, next one. What's the theoretical probability for rolling a number greater than 4? So you are not using the chart for this one, you're using what we've done before. So numbers that are greater than 4 are 5 and 6. So that means 2 out of 6, because you have 6 faces on a die. Plug that into the calculator, see what it reduces to. And you get 1/3. All right, next up, what's the experimental probability of rolling a number greater than 4? So this one you're going to use the chart. So greater than 4 would be 5 and 6. So it looks like you did that 10 times. So 10 out of 36. And that reduces to be 5 over 18. Alright, so what is the difference between theoretical and experimental? Well, so theoretical, I would say, is an ideal situation. Where you want to roll a 1, so you have a 1 out of 6 opportunity with a die. Experimental is what actually happens. So if you're going to look at the data chart. Alright, and then the last one, totally random. Okay? I don't know why I have this on here, but we're going to do it anyways. So if a car factory checks 360 cars and 8 of them have defects, how many will have a defect out of 1,260? So yesterday, Dan helped me out with this one. We divided 1,260 by 360. Because we want to know how many times that pattern repeats. And that will occur 3.5 times. So then you take 3.5 and you multiply it by the 8 cars that occur every 360. And that means that 21 will have defects out of the 1,260. Alright guys, and that was yesterday's lesson. I'm really sorry again about the video not having sound, and I completely did not realize that you could not see anything. So I hope this helps. I will make sure to do another video for today's lesson later today, and I hope you guys have a great day.